The sun breaks over the horizon in Austin, Texas, casting golden rays across one of the most advanced manufacturing facilities ever built by human hands. This is Tesla Gigafactory, Texas, a cathedral of innovation, a temple of technology, and the birthplace of the future. Spanning over 2,500 acres, this isn't just a factory. This is where the impossible becomes inevitable. This is where raw earth materials transform into vehicles that will reshape transportation as we know it. Every morning, thousands of workers stream through these gates. Engineers, technicians, roboticists, and visionaries, all united by a single mission: to accelerate the world's transition to sustainable energy. Austin, Texas, the heart of American innovation, now beats in rhythm with electric motors and the hum of progress. Welcome to Gigafactory, Texas. Welcome to the future. Look at those shapes. Angular, defiant, revolutionary. Those are Cybertrucks, vehicles that look like they've driven straight out of a science fiction movie and into our present reality. But how do you build something this radical? How do you take lithium from the earth, silicon from sand, and transform it into a machine that can travel hundreds of miles on pure electricity? The answer lies within these walls. The journey begins. Today, you're going to witness something extraordinary. We're going to follow the complete journey from raw materials to finished vehicle. We're going inside one of the most automated, most efficient, most futuristic manufacturing operations on planet Earth. This is the story of how Tesla builds the future, one electron at a time. The moment you step inside Gigafactory, Texas, you're hit by the sheer scale of it all. This facility could swallow entire city blocks. The factory floor alone spans 1.1 million square feet. To put that in perspective, you could fit more than 20 football fields inside this single building. But size isn't what makes this place special. It's what happens here. It's the symphony of machines, the choreography of robots, the precision of every single movement. Battery production, the heart of the operation. This is where it all begins, the battery production hall. Bathed in electric blue light, thousands upon thousands of machines work in perfect synchronization. If the Gigafactory is a body, this is its beating heart. Because without batteries, there are no electric vehicles. Everything starts here. Close-up of lithium-ion battery cells. Look closely. These are lithium-ion battery cells, the fundamental building blocks of every Tesla vehicle. Each cell is precisely engineered, meticulously crafted. Lithium, nickel, cobalt, and graphite, elements forged in the hearts of dying stars billions of years ago, now harnessed to power our journey into tomorrow. These cells will store the energy. They will hold the charge. They will give life to vehicles that produce zero emissions. Robotic arms assembling battery modules. Watch the robots work. Each movement calculated to the millimeter, each action timed to the microsecond. These aren't just machines, they're extensions of human ingenuity, performing tasks with a precision that human hands could never achieve. Sparks fly as connections are welded, components snap together with mechanical certainty. This is manufacturing poetry.
Now, let me tell you about something revolutionary. The 4680 battery cell. The numbers represent its dimensions, 46 millimeters in diameter, 80 millimeters in length. But don't let the simple name fool you. This is one of the most significant innovations in battery technology in decades. Traditional battery cells are smaller, which means you need more of them, more connections, more complexity. The 4680 cell is larger, more energy dense, and fundamentally changes the economics of electric vehicle production. Each cell delivers 5 times more energy than previous designs. They're cheaper to produce, faster to manufacture, and more efficient to integrate into vehicles. But here's the real genius. These cells eliminate the need for tabs, those small metal connections that traditionally carry current in and out of battery cells. Instead, the 4680 uses a tabless design, allowing for shorter electrical paths and dramatically reduced resistance. What does that mean? More power, better performance, longer range, and vehicles that charge faster than ever before. Temperature is the enemy of battery performance. Too hot and the cells degrade. Too cold and efficiency plummets. That's why every battery pack includes an intricate cooling system, a network of channels and conduits that regulate temperature with surgical precision. Glycol coolant flows through these passages, absorbing heat, maintaining optimal operating conditions. It's thermal management at its finest. Quality control at Tesla isn't just rigorous, it's obsessive. Laser scanners sweep across every surface, measuring tolerances down to fractions of a millimeter. Sensors detect the slightest imperfection. Every battery pack is tested, verified, validated before it moves forward. Because when you're building vehicles that people will trust with their lives, good enough is never good enough. Behind all this automation, human intelligence still guides the process. Engineers monitor real-time data streams, analyzing thousands of parameters simultaneously. Algorithms flag anomalies. Machine learning systems predict maintenance needs before failures occur. This is Industry 4.0 in action, the marriage of human expertise and artificial intelligence, creating a manufacturing ecosystem that's smarter than the sum of its parts. From above, you can see the flow. Battery cells become modules, modules become packs. Each pack contains thousands of individual cells, all working together, all synchronized, all contributing to a single goal, providing clean, sustainable power for transportation. The Gigapress, a manufacturing revolution. Now, those completed battery packs begin their journey. Autonomous guided vehicles, AGVs, transport them across the factory floor. No human drivers, no room for error. These carts navigate using sensors and algorithms, delivering components exactly where they need to be, exactly when they need to be there. And now, behold the Gigapress. If you've never seen one of these machines before, prepare to have your mind blown. This is the largest high-pressure die-casting machine in the world. It weighs over 400 tons. It generates 55,000 to 61,000 tons of clamping force. To put that in perspective, that's like parking 5,500 cars on top of a single point. Molten aluminum, heated to over 1,200 degrees Fahrenheit, pours into the Gigapress mold. The metal glows orange hot, liquid fire cascading into precisely engineered cavities. Then, in a fraction of a second, the press closes. Wham! 61,000 tons of force compresses that molten aluminum into a single-piece casting. What you're seeing right now is revolutionary. Traditionally, car manufacturers would assemble the rear underbody of a vehicle with 70 separate parts. 70 different components, all stamped individually, all welded together. A complex, time-consuming process. Tesla does it with one piece, one casting, one moment of incredible force, and you have a structural component that's stronger, lighter, and faster to produce than anything that came before. This is the Gigapress advantage.
This is manufacturing reinvented. Even with all this automation, human eyes still verify quality. Technicians inspect the casting, checking for any imperfections, ensuring structural integrity. These frames will carry passengers. They'll protect families. Every inspection matters.
Now, we enter the body assembly zone. And here, you'll witness something that looks less like manufacturing and more like mechanical ballet. Dozens of robots, each one programmed with precise choreography, work together to build vehicle bodies with stunning efficiency. Sparks explode in cascades of light as welding robots join metal to metal. Each weld must be perfect, strong enough to withstand crash forces, precise enough to maintain tight tolerances. The robots don't tire. They don't make mistakes. They execute their programming with relentless consistency, thousands of times per day. Watch as the skeleton of a vehicle takes shape before your eyes. What starts as separate panels and frames gradually becomes recognizable as a car. Roof, doors, side panels, floor. Each piece added in sequence, each connection verified, each step moving toward completion. Tesla's factories are among the most automated in the automotive industry, with automation rates exceeding 90% in some areas. But here's what's important to understand. Automation isn't about replacing humans, it's about augmenting human capability. Robots do the repetitive, physically demanding, dangerous tasks. Humans oversee, optimize, and innovate. It's collaboration between carbon and silicon, and it's redefining what's possible in manufacturing. Two very different vehicles share this line. The Model Y, Tesla's compact SUV with smooth curves and aerodynamic efficiency, and the Cybertruck, angular, aggressive, unlike anything else on the road. Different designs, different purposes, same manufacturing excellence. That Cybertruck body you're seeing, that's cold-rolled stainless steel, the same alloy used in SpaceX rockets. It's incredibly strong, naturally corrosion-resistant, and gives the Cybertruck its distinctive unfinished appearance. No paint required, just raw industrial beauty. Watch as robotic arms attach doors with millimeter precision. Too loose, and you get wind noise and water leaks. Too tight, and the doors won't close properly. The robots find that perfect middle ground every single time. Sensors verify alignment. Cameras check gaps. Nothing leaves this station unless it's absolutely right. Now we go inside the vehicle, where complexity multiplies exponentially. Modern electric vehicles contain miles of wiring, literally miles. Every wire must be routed correctly, connected properly, insulated adequately. It's a three-dimensional puzzle, and the robots solving it do so with inhuman patience and precision. The centerpiece of every Tesla interior, the touchscreen. This isn't just a display, it's the command center for the entire vehicle. Climate control, navigation, entertainment, vehicle settings, everything controlled through this single interface. Installation requires perfect alignment, secure mounting, and immediate connectivity verification. Even something as simple as seat installation is choreographed with balletic grace. Robotic arms lift the seats, position them perfectly, secure them with exact torque specifications. Every connection tested, every bolt verified, because safety isn't negotiable. Now watch this. This is one of the most critical moments in the assembly process. The battery pack, that massive, heavy component we saw being built earlier, is now lifted and mounted into the vehicle chassis. This is what Tesla calls the skateboard platform. Think about it. In a traditional car, you have an engine up front, a transmission, a fuel tank, an exhaust system, all these components scattered throughout the vehicle. In a Tesla, the battery pack forms the floor of the car. It's structural, it's integrated. It lowers the center of gravity, improves handling, maximizes interior space, and provides protection in a crash. This design philosophy, this skateboard platform, is one of the reasons Tesla vehicles handle so well, feel so stable, and offer so much interior room despite their external dimensions. Hydraulic robots attach the suspension system with force-controlled precision. Too much torque, and you risk damaging components. Too little, and safety is compromised. The robots apply exactly the right amount of force every single time. Now the vehicle enters the quality control tunnel, a gauntlet of sensors, scanners, and inspection systems. Laser measurement systems verify body panel alignment. Ultrasonic sensors check for hidden defects. Cameras inspect paint quality, looking for imperfections invisible to the naked eye. Human inspectors cross-reference digital data, confirming that every system is functioning as designed. Each vehicle has a digital twin, a virtual replica that contains every specification, every measurement, every data point from the manufacturing process. If anything is out of tolerance, it's flagged immediately. Final assembly. The pieces come together. Look at that, a completed Model Y rolling forward under its own power for the first time. What started as raw materials, lithium, aluminum, silicon, is now a sophisticated machine capable of traveling over 300 miles on a single charge. The Cybertruck assembly follows. Glass panels, including that famous armor glass, are fitted with robotic precision. The Tesla logo is engraved, every detail attended to. Tires spin in slow motion as they're mounted onto wheels. These aren't ordinary tires. They're specifically designed for electric vehicles with low rolling resistance to maximize range and reinforced sidewalls to handle the instant torque of electric motors. But a vehicle isn't finished just because it's assembled. Now comes the testing phase, where every system is pushed, verified, and validated. Rain cascades over a Model Y in a rain simulation chamber. Engineers are checking for leaks, verifying that seals are perfect, ensuring that even in the worst weather conditions, the interior remains dry and comfortable. The Cybertruck accelerates on an indoor test track, its electric motors delivering instant torque, pushing the vehicle forward with startling force. Acceleration tests, braking tests, handling tests, every parameter measured, every result recorded. Brake testing is critical. A machine simulates emergency braking scenarios, measuring stopping distances, verifying that the regenerative braking system works in harmony with traditional friction brakes. Lives depend on these brakes working perfectly every single time. Digital systems calibrate the steering, ensuring precise response, appropriate feedback, and perfect alignment. Modern vehicles are drive-by-wire. There's no direct mechanical connection between the steering wheel and the wheels. Everything is mediated by computers, which means calibration is absolutely essential. Software, the soul of the vehicle. Here's something that sets Tesla apart from traditional automakers: over-the-air software updates. The vehicle you're looking at will continue to improve after it leaves the factory. New features, performance enhancements, bug fixes, all delivered wirelessly, automatically, just like updates to your smartphone. Tesla's AI system is constantly learning, constantly evolving. Every Tesla on the road contributes data, helping the neural networks understand driving scenarios, improve responses, and enhance safety. It's collective intelligence on a global scale. 8 cameras surround the vehicle, providing 360 degrees of visibility. Each camera must be perfectly calibrated, its field of view precisely aligned. These cameras are the eyes of Tesla's autopilot system, and their accuracy is critical for safe, autonomous driving features. The infotainment system comes to life. Icons appear, graphics render smoothly. This is a computer on wheels, and like any computer, it needs to boot up, initialize systems, and verify that all software components are functioning correctly. Production scale, the power of automation. Look at this, rows upon rows of completed vehicles, each one representing hundreds of hours of engineering, thousands of precise operations, millions of lines of code. This is manufacturing at scale. From above, you can appreciate the sheer volume of production. Gigafactory Texas is capable of producing hundreds of thousands of vehicles per year. That's not just impressive, it's essential. Because if we're going to transition the world away from fossil fuels, we need to produce electric vehicles at massive scale. And behind all this technology, behind all these robots and algorithms, there are people. The workers of Gigafactory Texas aren't just assembling cars, they're building the future. Every milestone celebrated, every achievement recognized. Continuous operation, the factory that never sleeps. As the sun sets, the factory doesn't stop. The night shift arrives. Lights illuminate the production floor. The work continues. Because demand for electric vehicles is insatiable, and every hour of downtime represents vehicles not built, customers waiting, progress delayed. Through the night, the machines work tirelessly. Robots don't need sleep. Production lines don't require rest. It's continuous operation, 24 hours a day, 7 days a week, 365 days a year. The grand finale. One more Cybertruck rolls out, its distinctive silhouette unmistakable. Love it or hate it, you cannot ignore it. And that's exactly the point. The future doesn't arrive quietly, it announces itself boldly. A Model Y accelerates through the gate, its electric motors silent but powerful. 0 to 60 in under 5 seconds, 300 miles of range, room for 5 adults and their cargo. This is the vehicle that will electrify the masses. The Texas landscape stretches out before these vehicles, wide open roads, endless horizons, the promise of adventure powered by clean energy. Here's what you need to understand. Gigafactory Texas isn't just about building cars, it's about building a sustainable future. Every vehicle that rolls out of these gates is one less gasoline-powered car polluting our air. Every battery pack assembled here is one more step toward energy independence. Every solar panel installed on this roof is one more kilowatt-hour of clean electricity. The transportation sector accounts for nearly 30% of global greenhouse gas emissions. To address climate change, we must electrify transportation. And to electrify transportation, we need to build electric vehicles at scale. That's what this factory does. That's what this mission is about. We're not just manufacturing vehicles, we're manufacturing change. We're building the infrastructure of a sustainable civilization. We're proving that prosperity and environmental responsibility aren't opposites, they're partners. The final pullback. As we pull back for the final time, Gigafactory Texas becomes smaller, but the impact it represents only grows larger. This is one factory among many. Tesla is scaling up. Other manufacturers are following. The electric revolution is accelerating. Built in Texas, driven by the future. These aren't just words, they're a promise that American manufacturing can compete globally, a promise that technology can solve problems, a promise that the future can be better than the past. Final words.
The music swells, the emotions rise, because what you've witnessed today is more than manufacturing. It's transformation. From raw materials to revolutionary vehicles, from human vision to robotic precision, from fossil fuels to electric dreams. This is Gigafactory, Texas. This is where the future is built. This is where innovation meets production. This is where sustainability becomes reality. Welcome to the future of transportation. Welcome to the electric age. Welcome to Tesla's Gigafactory. The factories will keep running. The robots will keep building. The mission will continue. Because the transition to sustainable energy isn't a destination, it's a journey. And every vehicle built here is another mile traveled on that road to a cleaner, more sustainable future. One final glimpse. Robots welding, batteries assembling, vehicles rolling. The work never stops. The future never waits. And as the lights fade, remember this. The future isn't something that happens to us. It's something we build together. One vehicle at a time, one battery pack at a time, one factory at a time. From Austin, Texas to the world, from raw earth to sustainable transportation, from vision to reality. This